Hello, this is Mike Beeler. Welcome to our webinar today. We're so glad you joined us for the 21st Century Costs of Undergrounding. This is sponsored by Hoagland and PDI Squared, the Power Delivery Intelligence Initiative. With me today is Matt Raymond, and Matt is with Hoagland. And Matt, hello, and why don't you say a word to our audience today?
Hi, everyone. Just want to thank everybody for their time today on behalf of Hoagland. Myself, I have a fairly diverse background coming from large EPCs on the fossil fuel side, doing back-end technology refurbishments, transitioned over into the nuclear side, and then made a transition into the cable industry through ABB, and now Hoagland. So just a quick introduction about myself, and again, looking forward to this with Mike here, and hope everybody enjoys.
Thanks, Matt. We appreciate that. So today is the third in a series of 6 webinars that we're conducting on the life cycle cost and the reducing the cost of underground transmission and distribution. And of course, the article appeared in T&D World Magazine back in March. And this is the third in a series, and we're going to talk about civil construction today. So when we talk about the life cycle cost of underground, we're talking about the design and construction and ultimately the operations and maintenance. Actually, last month we talked about some of the material science that's changed in advancing the 21st century costs of underground. This is brought to you by the Power Delivery Intelligence Initiative. We call it PDI Squared, and that's a group of contractors, material suppliers, cable suppliers that are advocating for planners and engineers across America and North America to look at overhead and underground, evaluate the cost of underground. But when we say the cost of underground, specifically, we're talking about the life cycle cost. All of the costs through the life of the asset of underground. And of course, that is the engineering part of it, but the construction part as well. So today, Matt is going to talk about construction. And Matt, I'm going to turn it over to you for the next 30 or 35 minutes. I'd encourage the audience, if you have questions, go ahead and submit your questions. We'll take a look at those, and we'll spend the last 15 or 20 minutes going over some of the questions from the audience. So Matt Raymond from Hoagland, take it away.
Thanks, Mike. So I just wanted to kind of start off with giving a general idea of what the Hoagland Group does, kind of our lines of businesses and how that ties in and fits to underground transmission and distribution work. So by looking at the slide here, you can see that the Hoagland Group is the management company. And then underneath that, we have Hoagland Energy, which is our electrical side for overhead underground transmission, distribution, substation work. Grace Industries is our civil component. IMT is a material aggregate business that supports the civil side. And then we have Midnight Trucking, which is our transportation and logistics, moving equipment and materials around. And then right below that, you have Eastern Utilities, which is our directional drilling and trenchless technology company. So for us in the underground realm, we can provide kind of streamlined services in all these areas. So this allows us to deliver a full turnkey project to avoid markups on top of markups. So this can be a considerable cost savings for underground transmission and distribution work by avoiding the markup on your subcontractors. So if you look at it from markup of your first tier to your second tier, depending upon what that markup is, it could be anywhere to the range of 10 to 15%. It looks like this skipped around. I apologize. Sorry about that. So in this case, we are really concerned about more the underground capability side. So here,
well, Matt, let me just comment too, real quick. Matt, let me comment real quick, just for the fun of it. Is I like the fact that you're a full spectrum EPC contractor, because I think that's where when companies start to do not only the planning and design component of it, but the procurement of the materials and then the construction as well, they have a much better understanding of some of the things that can be done in the field. And so when we look at ways to improve civil construction, of the 21st century underground transmission and distribution system, I think an EPC contractor's got a leg up on many other types of contracting. So that's a great background at Hoagland. Appreciate that.
Yeah, thank you. And that's kind of the trend that we're seeing in the market is more of these EPC full turnkey type projects that a lot of utilities and developers are looking for these days. And so with that comes, really where our niche and focus is the underground capabilities. And you can kind of see here, it's a little bit of a laundry list of items that we do on the underground side. But through this wide area of expertise from the field to the office, we feel like we can help provide solutions for clients that may need an understanding on the constructability aspects of their given situation. So we're coming into this era really with underground transmission and distribution to where you have these older pipe type cables, HPFF cables. They're meeting their expiration date in major cities like New York City, Boston, Philadelphia, Chicago, for example. And with the cable manufacturers continuing to enhance their capabilities with the XLPE market, it's allowing us to look at these retrofit projects to where we can remove the old cable from these HPFF systems, clean out those pipes, and then pull in the XLPE cable, which is a tremendous savings because you're limiting yourself then with civil work. So really for today, I'm sorry, Mike, were you gonna say something?
No, I'm listening it away, Matt.
All right. So really for today, the underground construction strategies for successful project execution is what we want to cover. And through this slide, you can pretty much see that a lot of these items are nothing mind-boggling or new per se, but comprehensive design and site investigation, drawings and specifications, early collaboration with engineering and experienced contractors, constructability reviews, contracts and procurement, and project execution are really kind of the main focuses for today. So as you can see, it's a lot of pre-award items where planning is key for these projects to be successful. So on the
well, I will say one thing. I will say one thing. We know in strategic undergrounding for distribution systems in particular, and we've heard this from previous webinars that we've done, and even within this series, is that you've got to get out and communicate with the public. And so when you talk about pre-engineering and getting advanced work done ahead of time, is very important, fundamentally important, frankly, to get out and engage with the public, make sure they know what you're doing in their front yard or in front of their business. And so that is going to take some effort. And sometimes that happens before an EPC contractor may even get on the project. The utility or the asset owner may be engaged in that. Do you have any recommendations on how, Matt, how a customer like your utility customer might better engage you as an EPC contractor to get in and do some of that upfront work before you get drawings and specifications? I mean, are there things that maybe you've seen in your experience, or maybe somebody that you've worked with that's done it a pretty good way?
Yeah, I mean, so a lot of times you find that the utilities go directly to, say, a third-party engineering firm or an owner's engineer, and they're kind of relying on them to put together these designs, talk to the municipalities. Where, what we found is that when we get to talk to the utility directly and even developers in this case, we get to talk to them up front as they're looking at their design. We work day in and day out with municipalities. We're the ones actually in the community most of the time, so we have a very good idea of, the relationship with the local police, the municipalities, and we usually have drawings and stuff, even from prior jobs that may be going through an existing route or a new route, and we can help facilitate that. I think from an engagement perspective, it's just changing that mindset a little bit of, while contractors or constructors, you can look at it from a sense of they can provide some type of engineering data as well, or at least doing that constructability kind of check. And that's really what we're going to kind of cover today. hopefully that answers your question there.
Yeah, thank you.
Okay. So as you can see on this slide, the comprehensive design and site investigation, and this kind of covers your civil and electrical items. So from a civil perspective, identification of underground utilities. When these aren't identified and you don't have accurate drawings or engineering data, it causes to delay the schedule. There's cost implications like that, and there could be dangerous to the crews depending upon what type of utility it is. Same with electrical items, the conduit routing, cable pulling tensions. If that's not engineered, you could get to a point where you can't even pull the cable because the cable tensions are too high. And then from both the civil and electrical aspect, without those fully engineered drawings and specifications, you're getting delays on both sides, and the contractor can kind of, like I said, help add in some input there to then help avoid these issues. So with close coordination of the client engineering, subcontractor, construction, and municipalities, you really can avoid, hopefully, any cost impacts. We found that our local knowledge and others, I'm sure, in their local area can help avoid this downtime. As you can see with this picture right here, this is actually inside of a substation that was an old foundation nobody knew about. So if the utilities and others were able to keep up-to-date drawings, we could have avoided this or rerouted the cable. And this ended up costing, a couple days of downtime because it had to go through different engineering reviews, how we wanted to remediate the situation, whether it was rerouting the cable or removing the whole foundation itself. So, when you have a whole crew out there with equipment, I mean, you could be looking, depending upon the area that you're in, $25,000 or so of cost a day, just alone. So, it ties into our, early collaboration of engineering and experienced contractors. So the collaboration between utilities and contractors is really of the utmost importance. Everyone involved.
Yeah, Matt, and I think as an engineer, I think we've always advocated as engineers that we spend a little bit more time and a little bit more money on the front end, and we end up saving time in the field. So if we would have found that foundation, for example, we would have saved those 2 days. And so we need to spend the right amount of time. And so sometimes it's challenging because when an engineering firm, for example, is trying to propose on a project, they're going to say, well, we're going to give this many man hours to this, and they really don't want to go over that. Or a utility is looking at, and like you said, they don't have access, or maybe they don't even have drawings of old foundations like that. I'm sure that foundation is decades old. So a little bit more on the front end. That again, it speaks to the beauty of an EPC contractor, because when you're designing and procuring and constructing all under one hat with one area of responsibility, one person, one entity responsible for that always makes it, that's a great way to go. And I think we see the industry heading that way. And I don't know how much EPC Hoagland Energy does, if you do a little bit of just regular construction work as well. But anyway, I think EPC is a great way to go.
Yeah. I mean, and a lot of times, even for us, we'll bring in an engineer if it's not going to be something we'll do in-house, and a local engineer that again knows the local area. Because I mean, a lot of times what we find too is, you encounter the owner's engineer who's not familiar with the local area for what they're providing design drawings for, and for us, that early engagement with the contractors can help fill these gaps and provide details on these specific areas. So really, at the end of the day, the collaborative effort between the two can lead to better execution from a standpoint of the contractor and the upfront work, getting to know the real world environment, what that curtails when it's getting calculated into the drawings and specifications. And another example of this is a project we were trenching by a pond location, and the feasibility essentially just was unsafe and extremely costly of doing the trench. So we opted to go with a horizontal directional drill. And this is really, again, kind of leading into a good example of constructability reviews. Again, you would have saved downtime of crews, mitigated delays on the project schedule, and it ended up being that the HDD was more cost effective than trying to trench anyway. So tying into constructability reviews here, a lot of what we're seeing in the current climate, and I think it's really been a little bit of a trend here for a while, is projects are hitting the market with approximately 30% complete engineering. And this seems to be more on the renewable side, specifically for offshore wind. But if the developers and the utilities and engineering firms collaborate with contractors prior to release of RFPs, which don't have complete detailed sets of information, they can help avoid a myriad of assumptions in the bids that they're getting back by allowing contractors who do the work day in and day out to help kind of fill that in, so that when they receive bids, it's a little bit more comprehensive and everybody's on the same page as far as what's been assumed. So we've really been engaged here recently with multiple developers on the offshore wind market and their first tier subcontractors, which are themselves large EPCs, and helping them develop the U.S. market for offshore. The amount of estimated wind generation that's going to come in, and it's going to require a tremendous amount of onshore upgrades for not only the routing to the substation, but the substations themselves. So it's going to change really the footprint of underground transmission and distribution work. Many of these companies too on the offshore wind side are European, and they don't necessarily understand the landscape here in the U.S. and the applications of underground transmission and distribution is slightly different from what they're used to doing over on the other side of the pond. So by helping these developers avoid, routes through towns, dealing with multiple municipalities, and sticking really to like state roads and right-of-ways, they can cut down the cost of installation probably around like 25%, just by cutting out some traffic control. Again, longer schedules and more manpower needed to man the projects, because there's just so much more activity when you're going through these small towns and other areas. Also, instead of trenching sometimes in these areas, it may make more sense to utilize an HDD method to help avoid additional utilities that you're going to find in the ground. And these preliminary studies with constructability reviews can help gauge the cost of these projects coming to the market more accurately for their budgets, and allow for a stronger chance of approval by utilizing this local knowledge. And so we come into the contracts and procurement section.
Hey, Matt, let me ask you a question. Talk a little bit more about H&E. What is H&E, and how are you guys using that to improve the not only the constructability, I guess, but to get in on the front end and make some evaluations about maybe even some routes and such?
I'm sorry, you said H&E?
Yeah. What were you describing there?
In the previous slide was a horizontal directional drill. Is that what the HDD?
Oh, was it HDD? Yeah. Okay. Horizontal directional drilling.
Yes. Yeah. So I mean,
is that something you guys are using a lot of, and is that a pretty quick option that you can go to fairly easily? There was a time in the industry that using a horizontal directional drill, especially on transmission scale, that was pretty challenging. Is that more matter of fact now, and it's like, okay, just about every contractor's got the capability of doing that, or there's a good subcontractor out there that is able to come in and execute that? Yeah,
I mean, I think, for the most part, HDD is not for the faint of heart. You want to use the right contractor. You need to have the right equipment and the best knowledge to do those types of drills. I think what you're finding is that people or contractors are more proficient with the technology, and that the thing with the HDD is your footprint is smaller too. So you're having to dig up less of a road by doing linear trenching. it's less impactful to the community itself. So we've found that, I mean, we're fortunate in the sense that we have our own HDD company for small distribution and smaller transmission cable shots. But you know, there is a myriad of HDD contractors out there that are well qualified, and you know, again, with planning can make sure that they have equipment sourced for their particular job that you may need them for. It's specialty equipment, but it's not necessarily rare per se.
Thank you.
Yeah, no problem. Going on to contracts and procurement. So one thing that I've always kind of been an advocate on is avoiding the winner's curse. And really the winner's curse is winning a contract in which you and your subcontractor are ill-prepared to perform. This basically can result in a loss of credibility, damage to a reputation, and negative financial implications. So really, again, on the upfront aspect of any job during the RFP stage, like vetting all addenda carefully and providing reasonable timeframes for responses will save time in the end because you don't have that confusion on the backside. It also, like I said, allows for clarity with regard to expectations among the client and the contractor, just keeping everybody on the same page. And this next slide really will kind of give you a general idea, and I hope that's clear enough for people to see, of kind of what the growth can happen with on contracts from like their original award amount to, you know, what they actually end up costing. So with what we were talking about during the constructability review portion, that last 15 years here has been a trend of construction starting with 30% engineering being completed, which we found kind of drives up the cost. With engineering not being complete, again, kind of beating a dead horse here, the lack of details leads to multiple addendas during a bid. And this above chart, based on the data from another company that I worked for that's really no longer in existence, but this illustrates on a larger scale the problem with this issue and demonstrates how the approach is compounded, especially when you involve multiple disciplines. Even on a recent underground bid that we put together, there's 20 addendas and very short lead times to put together answers and digest the information. And this basically just led to the contract being let late or later, kind of confusion of what addendas were and were not included. And essentially you saw a contract increase of about 10% of the total contract value, which, you know, again, if in taking the time to vet these things, you can avoid on the front end and keep accurate budgets. So I'd really like to get into the project execution portion now. So really on the project execution side, again, there's a common theme here, and a lot of that is ensuring better communication throughout the entire project. Involve all parties in the meetings. A lot of times what we find is subcontractors aren't brought into meetings that directly affect their work because of contractual setup. For instance, on an underground transmission job we were doing in Newark, the route was passing through, that's Newark, New Jersey. The route was passing through a very tight and congested neighborhood with school zones, etc. And at the beginning of the project, the client was trying to coordinate with the community on using a 3-week look-ahead schedule. Now, while the schedule was still accurate, it didn't provide the details of the traffic control setup and where equipment would be. So this led to cars being parked in areas they shouldn't have been, cars being towed, and it just kind of became a mess from a community relations standpoint, and again, affecting schedule and standby time for crews out in the field now. So in this case, fortunately, the utility client recognized this and was able to remediate this issue by then coordinating meetings with us and the local community, local community relations coordinator, so that he could then fully understand the impact of what our equipment setup would be and match it to that 3-week look-ahead schedule. and give better information back to the community so that they were more well prepared of, well, all right, well, hey, now I'm not going to park my car in this section of the road tonight because they're going to be there first thing tomorrow morning. It really worked out well for everyone.
Yeah, Matt, does Hoagland use any kind of project execution tools, or do your utility clients, or maybe even some of the big AE firms that you work with, do they have tools that you like, that maybe are GIS based, that are able to track any kind of contact made from the public, track contracts, maintain schedules, show pictorially through geographic information systems progress on the project and things like that? I know that some big AE firms have got that. I didn't know, in project execution, if you as an EPC contractor like to use that as well.
Yeah, I mean, so what we've developed kind of here internally is we use a couple of different systems for project management, right? But we have a system now, especially that, for any type of civil work that we're doing, and it was a tremendous help on actually about 7 miles of underground transmission cable that we just installed in Long Island here, is we actually sent drones out, and the drones filmed the entire route, and in live time we could constantly update and track the progress of the project. And by doing that, we could give real-time feedback and pictures to the utility, so they could then go talk to the community and everybody, say, look, here's how much work's actually been done. You can actually see it. Here's where there's still some open trenching. Here's what's already been paved. It just, again, was able to put everybody on the same page. I mean, with the technology these days, there's a million ways to do something, but we found that using the drone technology was really the best way to illustrate that.
I think that's a great example of 21st century technology. It's a kind of an emerging technology in the last 4 or 5 years, and it's a great example of why we think that the cost of underground transmission and distribution is coming down. And that's a great example. Thanks for sharing that.
Yeah, no problem. I will say you do have to have trained FAA drone pilots, which we do have, but if anybody's looking to go down that route, please reach out and we could help you. But it was well worth it. So continuing on with the project execution points. So with this, you're kind of looking at reducing risk and again, potential costs, because we're looking at the reduction of costs for underground transmission and distribution here in the future, and sometimes that just comes with lessons learned. So cable manufacturers are looking at longer cable installations between manholes. And with these longer lengths being pulled, there's a slight complexity change with the installation setup with larger reels, etc. But you're eliminating splices, and you're then eliminating manholes, which are a very costly item. And also with this, as we kind of touched on before, Mike, you have the horizontal directional drilling instead of trenching. And really, at this point with the HDD technology and know-how of contractors, the installation time is typically quicker once you set up. You're reducing your risk profile for injury because you don't have as many people in a major roadway. There's less impact on the community because your footprint is really just in 2 sections instead of digging up the entire length. And you're saving money on rehabilitation because there's less surface area to then restore.
Yeah, we're always looking for ways, especially as civil engineers, trying to figure out ways to stretch out the distances between manholes and maximize what we can pull through a conduit system for sure. And that's applicable for transmission as well as some of duct-based distribution systems. Of course, some of that distribution is, especially residential utility distribution, is just going to be direct buried. Hey, Matt, you said one thing in there in the opening of your remarks on this particular slide about lessons learned. And you don't have to answer this directly, but before we're done today, I'd like to know how Hoagland learns. Okay, you have lessons learned from a particular project. You have men and equipment all over the country doing projects for different clients of various scale and scope, and again in lots of different regions. How do you share amongst your regional offices and amongst your project teams the lessons that you learn as a contractor? And you can think about that for a while, maybe come back to it, but I think that's a big thing that we need to do better as engineers and contractors, and especially as EPC contractors. And I'm going to suggest that I bet an EPC contractor probably finds a way to learn those lessons and then employ those lessons on subsequent projects. So you can comment about that a little bit later if you'd like, but I think we should talk about that for sure.
Yeah, and I mean, I'll touch on it briefly right now. I mean, I think for us, it's funny. It's such a simple thing, but it's open communication, especially within your own organization. And for us, we sometimes use internal newsletters, we'll call it, especially on safety items and stuff of that nature, to distribute to everybody in the organization. Because lessons learned, there's people growing with the organization as well. So somebody who's a project engineer right now may be running a project later. So you don't want to limit necessarily your distribution list of information when that person could, in 6 months, a year, 2 years, whatever it may be in a position to need that information and that lesson learned. So we found that, keeping everybody informed and generating kind of distribution lists of, how projects are going, any safety concerns and how things have been approached there. It's kind of a short answer of how we do it here at Haugland, but it seems to work well to keep everybody in the loop with ongoing projects and ways to keep getting better.
No, I like that newsletter idea. I think that's a great idea. And you mentioned the word safety too, and we haven't really talked about safety very much, but that's a fundamental part. And I would say that when you look at the 21st century design and construction of underground assets, that safety is a huge issue, as usual. And glad that you mentioned that.
Yeah, I mean, safety is of the utmost importance for us and everybody in construction. You want everybody to come to work and you want everybody to go home happy and safe.
Yeah.
So on the continuing on with the project execution side of this presentation, so what we've done here at Haugland, and there's other contractors that have done this as well, is training local splicing personnel. So you're not relying on foreign labor, whether that's foreign labor from out of state or foreign labor from overseas. Just in itself there, you're reducing risks, you're reducing costs and travel and expenses, et cetera. You're creating reliability in the market as well for repairs if needed, for the long-term, use of that cable. You're limiting then your downtime of outages due to quicker response times. And we've gone so far as to have guys trained overseas, to bring back some of that local knowledge, and then those guys can help train up-and-coming splicers as well. So we found that that's really been key for our success and helping provide a better quality product to the client, and helping trim some costs at the same time. And it's really worked out quite well, and I think that's, again, a trend, especially with the renewable markets coming up, that you're going to see more and more, is specialty type expertise like splicing is going to be more and more of a requirement for local labor forces. And then on the cable technology side of things, you have now fiber embedded cables. So you're reducing the amount of cable that you have to pull. This fiber is then embedded with the power cable. So instead of then having to do 5 pulls, you're only doing 3, or you're only doing 1 instead of 2 or 3. You're creating reliability into the system itself, which allows you to monitor the temperature of the cable for optimal use. So with a DTS cable, it provides continuous temperature monitoring of the power cables, detecting hot spots and thermal bottlenecks, delivering operational status, and condition assessments for particular circuits, which allows the utility then to run the cable as optimally as possible to get life out of that cable, and then to detect the problem sooner than later. And if they are starting to see a hot spot, maybe they know, all right, we have to order a splice, and they can to limit that outage time frame if they do have to make a repair.
Yeah, that's a great idea to run a fiber optic cable in there, and that's pretty common on transmission underground. Do you want to comment on, are you guys doing pipe type underground systems as well as solid dielectric? Most new underground transmission these days is solid dielectric, but in big, heavy urban areas, they still have a legacy pipe type system. What do you guys do as contractors these days? Where's the majority of your work going, Matt?
Yeah, I mean, I think the future is really the XLP market. We do HPFF and the pipe type cable installations. They're more repairs at this point than they are new installations. And that's kind of what I was touching on before with the retrofit projects is in these large urban areas like New York City, which is right around the corner from us. To replace that whole system and do all the civil work again is just a tremendous amount of cost, a tremendous amount of time in heavily trafficked areas. So what we're seeing is with these retrofits is they're entertaining and trying to develop and design ways to remove that dielectric fluid and that conductor, clean that pipe, and then pull in an XLP cable into that existing pipe. So this way you're basically eliminating the civil work that would take place on a new construction. So there's still a bunch of studies going on about that, and there's some utilities that are trying to put that into practice more often. I think it's really the wave of the future, I think, for a lot of cities, in the ways to keep the cost of underground transmission and distribution work really at a minimum.
I agree, and I think there'll be some opportunities down the road with superconductors along the same line as using reusing duct banks or pipe type systems that are there that come in with a superconductor. That's a ways down the road. We've been talking about that as an industry for a while. Here's a couple of questions from the audience that I think now is a good time to ask. The first one I'm gonna ask relates to the first webinar that we had, where we had IMCOR, and they talked about some of the testing that they can do right at the beginning once the cable's pulled to look at the condition of the cable, and then periodically come back and look at cable condition through the life of the asset. Do you guys see, as contractors, as EPC contractors, are you getting more specifications that are asking you to benchmark the condition of the cable system once you've built the civil system, you've pulled the cable in, it's spliced, it's terminated, and you're ready to commission it? Are you seeing specifications that are requiring you to bring in a company like IMCOR to do some benchmarking of the condition of the cable? You seeing any of that yet?
Yeah, I mean, speaking honestly, the testing we really see on the front end of things is more or less like jacket integrity testing to make sure that the jacket is good and that there's nothing wrong with it, it hasn't been damaged in transport, and then doing that test again after a pull. That's some smaller testing that we are fortunate to be able to do internally. And then really where we see the IMCORPs and others is kind of on the back end to do the full testing for doing a high pod or any type of DTS testing and fiber optic testing of that nature.
Okay. Here's another question from the audience as well. Any advice on cable technologies that can enable longer lengths and minimize splices? And it's kind of related to another question. What's the longest pull between manholes that you typically do? So, of course, that depends on cable size and lots of different things, the kind of environment you're in, urban environment, rural environment, and such, how many turns and verticals and horizontal turns you have, et cetera. But what are you seeing in terms of cable length of pole these days, let's say on 115 kV class style of dielectric cable?
Recently, we've seen some bids come out for some poles that are around 5,500, 6,000 feet poles. So you're pulling almost, you're pulling more than a mile at that point. I would say the longest that we've really done is probably around that 4,500 mark. And that technology really is kind of based on the manufacturer and their ability to run those longer lengths and be able to put it on a reel. And you are somewhat limited to your area too, weight restrictions of bridges and other things like that.
Right.
Being able to get this now large reel to that specific location. But from let's say a technology standpoint, I mean, there's for us on the construction side, it's just figuring out the way to handle that large of a reel, and that technology is there, and it's having enough rope on your winch to be able to pull that far, and that's the basic technology that's there. It's really from a more of a complication standpoint of the cable manufacturer being able to make sure that they can manufacture that length.
Right. Those are good points. A lot of ancillary things that we tend not to think about, but you have commonly done about 4,500 feet, but you're seeing some. Hey, when you say you're seeing like poles of 5,500 feet, are these from traditional utilities or more from some of these renewable developers?
Traditional utilities, to be honest.
Okay.
Sometimes they're connecting, one piece of land to a waterway. But to your point on the renewable side of things, they are looking to do that as well. There's a few renewable projects that are coming from upstate to downstate New York that we've been looking at that have 5,000, 5,500 foot poles, and that's in regular roadways.
Interesting.
But with that, you do have, with the longer lengths, to be honest, you get more cable tension. So with that cable tension, you may have to have some type of intermediate manhole or something, or a pusher at one end to help give a little bit more, help take off some of that tension as it's coming off the reel and as you're pulling on from the winch side.
Are you seeing equipment manufacturers coming up with any kind of new and different kind of equipment that helps you pull those higher tensions or pull those longer runs? Are you seeing any of the big manufacturers coming out with new equipment that intrigues you guys?
I mean, the technology there is fairly the same. I mean, there's always, for us, we're looking at different types of rope that is maybe smaller in diameter that can withstand more tension, so that you can get through smaller conduit and smaller cable, these longer lengths. Really the winches themselves, that technology is there. I mean, we have a myriad of winches that go from 5,000 pounds to 80,000 pounds for very large pulls. But I don't think there's really been so much a change in technology from the equipment standpoint, other than it's kind of project specific on what your needs are going to be, and then these equipment guys are manufacturing to those needs.
Yeah. Good. That makes sense. Okay, that's all the questions I got for you right now.
Okay. Really, the next slide is kind of a closing slide here. So, really what I'm hoping people take away from this is with proper planning, the best engineering information, and good communication, you can limit your exposure costs for underground transmission and distribution increasing. Underground construction is more invasive, but it doesn't mean that it has to come at an unreasonable cost. The technology, like I said before, retrofit projects, longer pole lengths, and HDD technology are already starting to cut these costs tremendously by limiting the civil scopes. I mean, civil is always going to be your largest cost when it comes to these underground installations. And if you can limit that's the best way to move forward. And there's companies out there with streamlined approaches and the properly trained personnel that can help reduce these costs and successfully complete these projects within budget. It's not only having the cool toys, it's knowing how to use them, and having the personnel out in the field that understand how the project flow is supposed to go and to be able to set it up for its best success. And that's really, like I said, through education, through additional splicers being trained, all these things tie together that keep reducing the cost of underground transmission and distribution work by just making people smarter, better in the field, all the way around.
Yeah, I'd agree with that. Hey, here's a question from the audience, and it's something that we really should have mentioned. It's about fluidized thermal backfill. And are you guys finding that there are advancements in low thermal row backfill that so that it dissipates the heat of the cable? Of course, that's an engineering component, but then you've got to place it in the field. This question revolves around how do you place a fluidized thermal backfill in a horizontal directional drill? How do you guys engage with that? Have you seen any kind of changes in many of the drilling bentonite slurries, any of the fluidized thermal backfills for handling the temperature and the resistivity of the soil? How about commenting on those things?
Yeah, I mean, I think for us with the thermal backfill, what we found, at least in trying cutting costs, and this goes again into preparation of the job, sometimes you can find that using a native soil to make that thermal backfill, some of that native sand and whatnot can help reduce those costs. As far as the placement of it, I mean, the placement, I don't think that technology has really changed so much. In regards to doing an HDD, I'd really probably have to. I'm not an HDD expert, and I'm not claiming to be, but we see bentonite being used on more like the offshore type poles, with the shot going out to the wind farm, to help with like thermal resistivity. As far as the I guess makeup of that bentonite or bentonite clay, that mixture, I can't really comment too much to that changing from a I guess.
Yeah, no, that driller's mud, that bentonite slurry probably hasn't changed very much for decades of time. And really, and that's more during the drilling operation. I guess I was just wondering if there was any kind of new advancements in the thermal backfill. So you've got the pipe in place, and now you've got to put in thermal backfill. Do you put it into the big conduit that maybe is going under the river, or do you surround the conduit and things like that? But that's an engineering question many times as well. So my general question was if there's anything new that you could comment on, again, when we're looking at 21st century costs of underground coming down.
Yeah, I mean, we typically, we don't typically fill the conduit itself with the cable in it, unless that's like I said, going through, maybe a lake or something of that nature to help with thermal factors. But yeah, I mean, I can't really think of anything in regards to that's necessarily changed the landscape yet. And there could be something out there that I'm not aware of. That's very, very possible.
Yeah. No, so I just would say that was a question from the audience, and we appreciate the questions. We had a couple of others that one was related to how many years is the life cycle of underground assets, and I don't know that, I think you and I, Matt, might be able to agree that that an underground asset probably has an accounting life of 35 to 40 years, but probably could really live. That cable in conduit could probably last 40 or 50 years. And frankly, when we were talking to Incor on the first of the series, they were looking at even decades longer than that. So if the cable is properly installed and it's a good quality cable and it meets it meets the specifications of the material manufacturers, or the material like Dow's material that goes into the cable, and then you benchmark the condition of the cable when it goes in, and you know that there's not going to be any kind of infant mortality. There's no reason why you can't expect 50 years or more life out of that cable. So anyway, so that is probably about the last question from the audience. Somebody's asking about an approximate cost of horizontal directional drilling per kilometer, and in rough numbers. And Matt, I don't even know if you want to stab at that. There's so many parameters that impact the cost of a directional drill. Do you want to generally comment on just the general cost of a directional drill?
Yeah, I mean, it's a tough one because it's so dependent upon the area. Really, what your footprint is. Are we talking about in farmland? Are we talking about in a suburban area? Those costs are going to vary quite a bit, and it really depends on the size of the bore.
Right. Yeah, there are so many parameters. So I appreciate that question from the audience, but I will say there's so many parameters, and that's why if you're going to do a directional drill, you do need to have an owner's engineer, or you do need to have an EPC contractor that has that engineering technical background to be able to address that, because there are a lot of parameters, and at some point in time you say, hey, we got to get under this river, so we're going to drill it, and do you run into sand? Do you run into cobble? When I was at Hawaiian Electric Company, we were going to do directional drills down the streets of Honolulu, and how big is my equipment, and where's the water table, and oh, by the way, what do I do with the effluent that comes out of the trench? All of these are big questions that you need to address when you're looking at doing. I would say the bigger cables, more of a transmission type of project is where you're going to get into most of your directional drilling. Now, the mini directional drilling, and you're going down a neighborhood street and you're just going from, block to block to block, that is a much simpler concept, and that's probably not where you're going to need to use directional drilling. So would you say that's a fair assessment, Matt?
Yeah, I would say that's absolutely fair.
Okay. So, Matt, we're getting ready to wrap up here, and I'm going to ask you to make a couple of concluding remarks here. I guess my conclusions were listening to this, and how are we as an industry seeing the costs of, and I want to say life cycle costs of underground electric transmission and distribution coming down? How are we seeing that here? So this is 2021. Look, we see design tools improving. We see construction means and methods improving. We see better ways to operate and maintain, where we've talked about the materials that go into the cables. We've talked about ways to benchmark the conditions. So you take all of these things, and we see in general that the costs of underground transmission and distribution are coming down. Today, we really focused on the civil costs, and I heard you talk a lot about communication and coordination, and I appreciate that. I appreciate the fact that an EPC contractor can probably do that better than most, not perfectly, and I say better than most. There's others that will do a good job as well, even independently, as contractors and independently as engineers. We talked a little bit about horizontal directional drilling and some of the applications, especially on transmission for that. You talked about new technologies related to drones and how drones work with providing more information, more data that we turn into information that we ultimately turn into action for utilities, and a monitoring process with using a drone that monitors the progress of projects. And then I love the conversation about lessons learned and how you guys at Hoagland then share some of those lessons learned amongst all of your project managers, all of your crews, no matter what part of the country they're in, and really relate it and through internal newsletters and such about safety and means and methods and such. And then we were able to answer some questions about pulling tensions and fluidized thermal backfill and things like that. So I think we had a really good discussion, Matt, about the civil costs of underground transmission and distribution. And I'd ask that if you wanted to just take a couple of minutes and tell the audience thank you and give some concluding remarks, now would be a great time to do that.
Yeah, no, again, I just, on behalf of Hoagland, just want to thank everybody for their time. Really appreciate the opportunities from PDI and yourself, Mike. And, again, I think as underground transmission distribution keeps moving forward, the technology keeps getting better, and the ways through either lessons learned or just understanding how the technology is evolving, we're going to keep bringing the costs down. And it's going to be, I think you're going to see more and more of it. Like I said, even with the renewable side, it's just going to require a lot more underground transmission and distribution.
Well, that is absolutely a great statement, because we know with utilities that are looking at strategic undergrounding, we've seen what Dominion's done, Georgia Power, PHI. We just had a great video from Florida Power and Light talking about what they're doing with their Storm Secure program. And then you talked a little bit, Matt, about some of the offshore wind that is going to need undersea cables that are going to then come onto shore. They're going to come on shore underground. And then they're going to go into substations that don't likely exist today. And a lot of that onshoring is going to require underground transmission systems. So there's going to be a lot of great opportunity there. Again, a lot of great opportunity at the distribution system with doing the strategic undergrounding. And so we have a great reason to be bullish about more underground. And we can be confident as planners and engineers that we'll see more underground, because in fact the price is coming down. That 21st century life cycle cost is coming down. So on behalf of Hoagland Energy and Matt Raymond, and on behalf of the Power Delivery Intelligence Initiative, this is Mike Beeler saying thank you very much. We appreciate you listening in today. Be back with us again on June the 30th, when we'll have Centuri, another big civil contractor in the country, to talk more about what they're doing, what they're seeing with regard to means and methods and the reducing the cost of civil construction in the design and building of underground distribution, transmission and distribution. So, Matt, thanks again, and everybody have a great day and be safe.
Thank you.